I'm Anil Kumar, and with the help of this video, we'll try to understand how to solve questions relating permutation and combination. Here we have two questions. The first one is, in how many ways can Abel, Bob, Charles, David, and Edward fill the positions of president, vice president, and secretary? Part B is, in how many ways could these same five people form a committee with three members? So these are two questions for you. Let us see and understand these questions. Now in the first one, we have five persons. Let me call them as A, B, C. Let me say A, B, C, D, and E, right? Now in this question, what we observe is there are five persons who need to fill three different positions. So that ways the positions are distinct, right? So you can consider these to be three different positions, and since there are five persons, for the first position, let's say president, one of the five could fill this up. Once we have one person here out of this list, then four are left to fill the next, and once that is filled, three are left to fill in the next. And therefore, using the fundamental principles, we can find that the number of combinations is 5 times 4 times 3. 5 times 4 is 20, times 3 is 60. So we get answer as 60. Now you know permutations. So these are 60 different combinations. We could also find this using 5 P3, since there are 5 persons to fill 3 positions. Now 5 P3 is equals to 5 factorial divided by 5 minus 3 factorial. That is 5 factorial divided by 2 factorial, right? Or it is same as, let me write this as 5 times 4 times 3 times 2 times 1, right? 2 times 1, and that gives you the same answer as 5 times 4 times 3, which is 60, right? So in part A, since we have three distinct positions, right, they are all different, unique, and therefore we use permutation to find the total number of combinations. Now let's look into part B now. It says, in how many ways could these same five people form a committee with three members? Now when we are doing committee with three members, then in a committee all the members have same position, right? So everyone in the committee is equal. So in this case, everyone is, you can say, equal position, right? Is having equal position. So the order does not matter, right? So therefore, order does not matter. What I'm trying to say here is, if I fill the position with, let's say, Abel, Bob, and Charles, a committee with three members, then the order BAC or CBA, all these three are kind of same. Do you see that? So this committee has same three members, for example, correct? And therefore we see that in the second case, order is not important. Now in this case, how many combinations are there? Well, this is the case of combinations, since order is not important, right? So what we find here is that the number of ways it could be done is 5C3, which is equal to 5 factorial divided by 3 factorial times 5 minus 3 factorial, Or if you calculate this, we know 5 factorial divided by 5 minus 3 was 60, right? So it is 60 divided by 3 factorial. You will recall from here that 60 is the case when we assume that these three positions are different, right? Now 60 has been divided by 3 factorial because 3 persons in a committee will form 3 factorial permutations. You see that? So that is what it is. So it is 60 divided by 3 times 2, which is 6, and so you're left with 10. So in part B, the number of ways in which 5 people can form a committee with 3 members is 10, correct? And I hope with this you understand how and when we should apply permutation and when should we apply combination and how are they related. So in general, the relation between the two is that NPR is equal to R factorial times NCR, right? Or you could write NCR equals to NPR divided by R factorial, right? So that is the relation between the two. I hope with this example it is very clear when to use permutation and when to use combination. In the coming videos, we'll explore further with more examples on forming committees with different conditions. I'm Anil Kumar, and I hope with this the concepts will be very clear to you. Thank you and all the best.